to CEC lectures. Myself Dr. Preeti Chakwani. I am from Department of Computer Science, Aryabat College, University of Delhi. So in our previous lecture we have covered precisely two topics, one which was parameterized constructors and another one was about this keyword. So taking this topic of constructor forward in this lecture also, we are going through a very important type of constructor, I can say, and that is titled as copy constructor. Now, as the name indicates, copy constructor, that means I can say that this constructor is used in order to create an exact copy of the existing object of the class. So, for example, we have a constructor and within the parameter, rather than passing some primitive types, we are passing an object. And the what will be the job of the copy constructor? The copy constructor will create the exact copy of that particular object which is supplied as the parameter. And also if we have made any changes in the copy, it should not reflect in the original one or vice versa. That means we have made any kind of changes in the original one, it should not reflect in the copy also. So basically I need to, I can say, create a duplicate of that object, just not. And please recall the scenario of I can say creating different instance variable in which we have taken one two objects are being created, and those or we can say two references are being created, and both the references were pointing towards the single object. Here it is not the scenario. Here I can say the copy of the object is being created, and for such cases Java is providing the concept of the concept of the copy constructor. Now why I am saying the concept of the copy constructor? Because some of the programming languages such as C++ are having an inbuilt copy constructor, but in Java there is no such inbuilt copy constructor, but programmer can create their own copy constructor by passing the object of the same class to the other instance of the class. So functionality of copy constructor needs to be programmed by the programmer here, and no inbuilt copy constructor is available. So that's why I have told you Java provides the concept of a copy constructor, not the I can say an some inbuilt copy constructor. So basically this copy constructor is going to return duplicate copy of an existing object of the class, and I can say it is obviously a special type of constructor which is used to create an object using another object, but these two objects should be of the same class. So let's say I am having an object which is having multiple fields, and I want the copy of that particular object. So in order to create copy of an object with multiple fields, we can use copy constructor, and we can also have a deep copy of some kind of heavy objects, in the sense which are having too much of data within them. And another kind of method to do this copy is using the clone method, but if we don't want to use the clone method, we can use copy constructor. So copy constructor is there to create a copy of an object, maybe with the multiple fields, or a small number of fields. Now advantages says that it is easier to use a copy constructor if your object is having multiple fields, rather than taking each and every field and assigning it to the kind of other object, making in order to make a copy. It's better to have a copy constructor, and also the addition of the field or addition of this attribute to the class will be easy because of it, and because we need to change only in the copy constructor. And in the previous lecture we have seen the parameterized constructor. So parameterized constructor, we are in parameterized constructor we were passing the objects, we are passing the primitives, we have passed, if you can recall the last box constructor which was parameterized, we have passed three double parameters W, H and D. But here, unlike the other constructor, copy constructor is passed with another object which copies the data available from that parameter or that passed object to the newly created object. Now, in order to understand this whole concept, let us go with a particular program. In this, the first statement of this program says import java.util.scanner. Why this is being used, I will be telling you on the upcoming slide. So, here we have started with a public class which is named as student. It is having some fields or some variables which are roll number, age and string. So, as of now you can kind of ignore the word private and public, because we have not started or we have not discussed the access modifiers. And within this we have a constructor student, and this student is being passed with the name which is of type string, age which is of type integer and roll number which is again of type integer. And these three parameters are actually compatible with the data type of the instance variables of the class student. And we have also already seen the use of this keyword. So, we have written this dot roll number is equals to roll number. So, whatever will be the value of roll number passed passed, I can say, in the parameters, that will be assigned to the roll number of the invoking object. Then this dot name is equals to name, and similarly this dot age is equals to age. So, this is actually, I can say, a normal constructor which we have seen till now. In order to make a copy constructor, we will be passing an object of the class. So, for example, the object of the class is S1. So, within this student, so here we have written public student. So, that means this student is student is the constructor, because the name of the class is student, and within this as parameters I have passed in the earlier examples we were passing double W. So, here we are passing student S1, that means S1 which is of type student. Now, as student is a class, S1 must be an object. So, we have passed S1 object of the class student as a parameter to this constructor which we are calling as copy constructor. And here what is happening, S1 dot roll number will be initialized to this dot roll number, S1 dot name will be initialized to this name, and S1 dot age will be initialized to this dot age. So, essentially this says that whatever are the parameters roll number, name and age of the object S1 will be assigned to the roll number, name and age of the invoking object, because this here the keyword this is referring to the object which is being kind of invoked, or which has called this constructor, I can say. And then I have a simple method which is a display student method, in which I am just doing nothing, that is system.out.println, I am printing roll number, and with the similar statements I am printing name and age also. And coming to the main method. Now, within this main method we will be taking three parameters. Now, please recall that till this time we have used system.out.println in order to, I can say, supply the values, or in order to print the values, but we have not considered any program in which we are taking the values, or in which we are taking the input from the user. So, the library, or the, I can say, this which we have written import java.util.scanner, this is basically kind of, we can say, imported in order to give us the facility of kind of asking the input from the user. And how are we going to ask? So let's say the statement says enter your name, and whatever name will be entered will be kind of stored in a variable name which is of type string, and who is going to give the value to this name, that is scanner dot next. That means whatever next value will be typed on the keyboard, that value will go inside this name. So this is a way of taking input. We will be talking we can say much on this taking input in our upcoming lectures, but for till now this is kind of this is sufficient for us. Similarly, when I say enter your roll number and I am expecting a roll number to be typed by the user, then integer roll number is equals to scanner dot kind of next int. So next int is a method of scanner, and similarly for age I am using int age is equals to scanner dot next int. So basically within the I can say main function, or within the main method, I have asked 3 values from the user, which are name, roll number and age. And suppose user have kind of entered some values, like in the place of name it has entered Kavya or something else, then roll number something 36 and age let's say 22 or something of that sort. Then we have used a constructor here, in which we are saying student S1 is equals to new student name, age and roll number. So basically what we have done in this particular line is actually we have created one simple object which is S1. This object is of type student, or this object is of class student, and this has been initialized as with the variables name, age and roll number, whose values have been just kind of taken from the user and it was shown on the previous slide. So basically this is, I can say, this is a parameterized constructor. So using the parameterized constructor of the class student, we have created one particular object which is named as S1. And if we want to, I am calling this as an original object. Why I am calling this as an original object? Because I in the upcoming code I will be creating the copy of this particular object. So in order to print the value of this, or the value of the variables of the original object, we will be calling display student method along with this S1. So S1 dot is display student, and as far as whatever the functionality of display student is written, that is actually to print all these instance variables which are name, age and roll number of that particular object. So we have created one object using a parameterized constructor, and we have printed the values. Now on the next step we are going to use kind of we are going to use the concept of copy constructor, and we have already designed a copy constructor in our previous which was shown in the previous slide, and that was in a different class. So here in a different class file I can say. So in order to use that copy constructor, we have used student, then student underscore copy will be the name of the copy constructor. I could have used S2 here, is equals to new student and within the bracket S1. So that means a copy of the uh, object which is being passed inside the copy constructor, which is S1, has to be created, or an exact replica has to be created, and whatever will be the reference name to that particular variable is student underscore copy. So now I am having two different we can say objects. One is S1 and another one is student underscore copy, and these two are kind of we can say same having the same data, but the objects are actually different. And if we are going to perform any changes in the S1, it will not reflected into student copy, or vice versa. If I am going to perform any changes into student copy, that will not be reflected into S1. And in order to print the contents of the copied object, we will be using this display student with student underscore copy, which is the name of our new object or copied object, I can say. So this says student underscore copy dot display student. Now here this program kind of I can say ends, and if we are going to run this program, what output we are going to have is, first as per this main function, it will ask for the name, then it will ask for the roll number, and then it will ask for the age. And then after creation of one particular object which is named as S1, and I am calling it as original object, contents of these original object will be I can say printed on the screen with the functionality or using the functionality of display student. And on the next line I have used a copy constructor, and by using that copy constructor, this another copy of this object S1 is being created, which is named as student underscore copy, and using the display student function, the contents of that student underscore copy are also being displayed. So here is kind of I can say the output. Enter your name, someone has kind of entered, let's say Kavya. Enter your roll number, the data which is entered is 36, and then it will ask for enter your age, and it is 22, and it will say contents of the original object, because that we have written in the println statement. So contents of the original object, roll number, name and age, and after creation of the copied object, it will also display the contents of the copied object, which are nothing but same, which are roll number 36, name as Kavya, and age as 22. So we have created one kind of we can say what one object, and that object has been passed to copy constructor, and that copy constructor, by the virtue of the functionality written into that constructor, has created one object or one replica of that S1 object. So the contents of both existing and the copied object are exactly the same, and invoking the copy constructor by creating a new student object and passing the existing object in the copy constructor as an argument, that we have done. While the two objects are there, contents of both are I can say similar. So here till this point in this lecture we have understood the concept of copy constructor. In the previous lecture we have seen the default constructor as well as parameterized constructor also. Now our upcoming topic is about overloading constructors or overloaded constructor, I can say, and that is also kind of I can say a type of constructor. But before going into this overloaded constructor or overloading of constructor, we need to understand this topic of overloading or the concept of overloading. So first of all, let me tell you that overloading is actually one of the ways through which Java is going to implement, or any object oriented programming language is going to implement its the feature of polymorphism. So please recall our features of object oriented programming languages. We have apart from classes and objects, we have abstraction, we have encapsulation, polymorphism and inheritance. So this polymorphism is being implemented with using a variety of techniques, and one, or I can say the most simplest one, is actually the overloading, which is used to implement this polymorphism. Now overloading, technically speaking, what actually this overloading is, this is defining two or more methods within the same class, and these methods are sharing the same name of these 2-3 methods are same, but the parameter declaration, or I can say the prototypes, are different. So prototype includes your parameters and as well as your return type also. So with different prototypes but the same name, if there are 2 or more methods in one particular class, that situation is known as overloading, or we can say the methods are said to be overloaded, and the process is of method overloading. Now when an overloaded method is invoked, or I can say when an overloaded method is called, Java system is going to use whatever type you have kind of specified for the parameters, whatever the number of arguments or number of parameters. So differentiating on the type and number of arguments, Java will take a call that which particular method is actually to be, which overloaded method is actually to be invoked. So, first at a first glance, this method of overloading seems that why actually this is required. We will be looking into the need of the overloading in a short while. But here it one thing which is kind of very important is the overloaded methods must differ in either the type or in the number of their parameters. These overloaded methods may have different return types, but having only different return types is not sufficient to distinguish two versions of a method. So, for example, I am having a method f1 with two parameters and both are integers, and the return type is, let us say, character. And on the other hand, I am saying a return type is double. The method name is obviously the same because I am talking about overloading f1, and it is having two similar parameters, that means two integers. So, what is actually different here is just the return type alone. So, having return type alone is actually insufficient to distinguish between two versions of a method. Although the overloaded methods may have different return types, but it is necessary for them to differ either in the type or in the number of their parameters. And in case of a call to an overloaded method, it simply executes the version of the method whose parameters matches the arguments which are used in the call. So, in this way this overloading kind of we can say takes place. Let us see this with the help of an example. So, in class I have taken one method which is void test, and please see that this test is not having any parameter, and within this test I have written system.out.println, no parameters. Another method in the name of same test, that means an overloaded method which is having one integer, printing that value of integer. Then another method within the same class, another method with the same name, having two parameters, two integer parameters, integer a, integer b, printing the value of these two variables. And finally, the fourth version of that particular method which is named as test, having a different return type which is double. The earlier versions were having void, and this time the parameter is also different because this is mandatory, double a, and this is printing and this is returning, this is printing the value of a, and this is returning a multiplied by a. So, here in this program you must notice that one one version of test is not having any parameters, a return type void. Another version of test, one integer parameter, return type void. Third version of the same function test, two integer parameters, one return type void, and fourth one is return type double and one kind of I can say one double parameter. Now, in order to use this, we are going to create an object of this particular class which is named as overload demo. Here the object name is OB, and we will be calling all these methods using this object OB. So, we will be calling ob.test, then ob.test 10, we have supplied a parameter 10, then in the next call we have supplied two parameters, and then in the fourth call we have supplied a double parameter and also taken a return value and stored it in the variable result and we have printed the value of result also. So, the first call ob.test will be resolved using the call to the method which is not having any parameters. Next call ob.test within the bracket 10 as the parameter will be resolved with the version of the test having one integer variable. Next call will be resolved using the version of the test with two integer parameters, and finally ob.test, which is having 123.25 as parameter, will go to the last version of the test function, and this will also return a double variable. So in this way you can see here that different calls to the function test are having different parameters, one with no parameters, another one with one, next one with two integer parameters, and the final one with a double parameter. So in this way this concept of overloading is actually taking place in any of the programming object oriented programming paradigm, and as I have already told you that this is something which is kind of used to implement the polymorphism, and this program is generating the following output, which is obvious: no parameters from the first call, value of a is equals to 10 from the second call, value of a and b 10 and 20 from the third call, and value of double a at 123.25 and its kind of square, which is a multiplied by a from the fourth call also. So in this way your overloading is going to I can say take place here, but this overloading kind of we can say lot many much of the concept of this overloading is still left, which we need to go in our upcoming lectures. So here in this lecture we have gone through the concept of copy constructor, and then we have seen the idea of overloading. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I'll see you in the next lecture. Till then, take care. Goodbye.